Hello everyone and welcome back. My name is Mr. Kovalt, and in this video I'm going to be going over how to write formulas for acids. So in this video I'm going to talk about how you can go from the name to the formula for an acid. So in doing that, you need to distinguish between the two kinds of acids. You have the binary acid, which is just made up of hydrogen and some other element, usually halogen. And then you've got what are called the oxyacids, which is made up of hydrogen and some form of a polyatomic ion with oxygen in it, like a sulfate ion or a phosphate ion or a sulfite or nitrate or something like that. So you need to be able to distinguish that from the name, and I'm going to show you how to do that. So first, we have hydrogen bromic or hydrobromic acid. So the first thing you'll notice is that it begins with hydro. Anytime you have an acid that begins with hydro, it is a binary acid. So it's not an oxyacid. It doesn't have oxygen in it. It's just going to be hydrogen and some other element. Again, usually a halide of some sort. So here we have hydro. So the hydro is referring to hydrogen. So that's going to be one of the two elements in the binary acid. So hydro is a binary acid, which means that you have two elements. One of them has to be hydrogen in order for it to be an acid. So hydro refers to hydrogen. And then bromic is the referring to the other atom in your binary acid. So bromic comes from bromine, and so the other element is bromine. So we write Br, and there you go. It's HBr is a formula for hydrobromic acid. Okay, next we have sulfuric acid. Notice there's no hydro in the name. It doesn't begin with hydro. So therefore, this is an oxyacid. So this is going to be hydrogen with some other polyatomic ion. Okay, so here, notice that if we assume this is an ionic substance, it's not ionic, it's covalent. But if we were to assume it's ionic, uh, H would have a positive and bromine would have a negative one. So positive one, negative one balance out. So that's why you only need one hydrogen for each bromine. So there's one each in the formula. For sulfuric acid, since we know it's an oxyacid and therefore we're going to have a polyatomic ion that has oxygen in it, we're going to need to balance the charge with the hydrogen. So sulfuric is referring to the sulfate ion. How do I know it's referring to the sulfate ion? Is because of the IC ending. So if you don't have hydro and you have an IC ending, that IC ending came from the 8 form of your polyatomic ion. So since we have sulfur or sulf, which is sulfur, that means we're referring to the polyatomic ion that has sulfur. That would be sulfate. So sulfate is SO4. SO4 as a sulfate ion has a 2 minus charge. So if we're thinking about hydrogen having a plus charge on it, we want to balance the charge. And so we would need two hydrogens to balance that charge. So we would have an H2 in our formula. So we get rid of the charge because this is not a polyatomic ion. This is not an ionic substance, but we can come up with the formula by thinking of it as if it were an ionic substance and balancing the charge with enough hydrogens to balance the charge on the polyatomic ion. Okay, so H2SO4 is the formula for sulfuric acid. Now, what about hydrofluoric acid? So again, we have hydro, so that indicates that we have a binary acid, not an oxyacid. So there's no polyatomic ion here. It's just hydrogen plus another element. usually a halogen. So here hydro is our hydrogen, so we have H, and fluoric is referring to the fluorine, right? Fluoride ion, right? So here the IC ending is just the ending for the second element in your binary acid. Here the IC ending was indicated as replacing the ATE ending for your polyatomic ion, but here it's just the ending that we give for the second element here, fluorine. So again, if we think of fluorine as being a fluoride ion with a -1, then you need a positive hydrogen to balance that out. And so HF is the formula. Again, not an ionic compound. It is a covalent compound, but it's helpful to think of it as ions to balance the number of atoms you need. And then finally, we have phosphoric acid. Again, there's no hydro here. So this is a polyatomic ion-based acid. It's a oxyacid. So one of the elements is going to be hydrogen, of course. So what is the polyatomic ion? Well, we have phosphor and we have an IC ending. Remember, the IC ending indicates that you have the 8 form of the polyatomic ion. If you had an OUS ending, us, so if this was phosphorus acid, then that OUS ending indicates the ite form or the ITE form of the polyatomic ion. So here we have the ATE form, so that would refer to phosphate. So that would PO4. And that phosphate ion has a 3- charge on it. So that's helpful for helping us balance the charge. So we would need 3 hydrogens with a plus to balance the charge on the phosphate ion. So here we have H3. So we can get rid of this, and H3PO4 is the formula for our acid. Again, this is not an ionic substance. It is a covalent substance, but as you know, acids, when you throw them in water, they will ionize and become ions, but these are not ionic substances. But again, it's helpful to think of them as if they were ionic substances, so that way you can balance the charge and get the correct formula. I hope this is helpful in writing the formulas for acids given their name. Again, you got to be able to distinguish between the binary acid and the oxyacid. I hope this video is helpful in doing that. If you enjoyed this video and this helped you a lot, then please by all means like the video, share the video, hit that like button over there. Also, make sure that you subscribe to my channel. Hit that notification bell, and when you do, make sure you click all so you can be notified by all the videos I put out. And finally, put a comment down below in the comment section. Let me know what you think. Ask me questions. If you have a problem you want me to go over, if you have a question or a concept you want me to do a video on, then please by all means share that with me down below. I would love to do that for you. Thanks for joining me, and have a great day.